So today we are going to be talking about future careers in economic geology and how technology is influencing and potentially disrupting the future. So the conversations that we're going to be having today are really just talking about the panelists' careers and also how they've used technology in their career and some advice they have for everyone's future career as well. And SCG would like to take a moment and thank MapTech for the support as our technology and exploration webinar series sponsor for 2022. And this is actually the last webinar of the 22 series, and we will be chatting more about next year's at the end of this session. So stay tuned. I am your moderator today, Maureen Moore-Roth. I work at MapTech and I get to be an economic geologist helping people leverage and really utilize technology, and I get to help empower all of the geoscientists in North America here. I'm happy to explore more if anybody is looking for mentorship. I'm also an SCG fellow and a mentor there as well. So for the session, we are going to kind of have a mini session, mini lecture built into this panel discussion. We'll talk about the mining cycle and its importance and how all of our roles really fit into it. We'll have 3 presentations from our panelists, and then we'll open up into more of a conversational panel discussion where you can submit those questions as you have them or during that time period. And the panelists and myself will kind of talk amongst ourselves and with you to explore those questions. So the mining cycle, I really think it's important that every day we're thinking about how our roles and what we're contributing to the economic geology industry and geosciences, and really putting those pieces together so that we can understand, are we contributing in the exploration, or maybe we're contributing in the reclamation side. And so throughout this session, you will see how the presenters and panelists are really contributing to the science and just thinking about what's next. So first up, we have Liz Stock from Berwick. Liz has received a master's in geology from Imperial College in London, where she worked on the Red Dog deposit, assessing the regional breccias and deciphering paleo-hydrothermal fluid flow. She went on to study a PhD at the Mineral Deposit Unit at the University of British Columbia, where she studied the Red Lake gold mine in Ontario. And the aim of that study was really to understand the evolution of the deposit, as well as documenting the alteration zonage of future exploration efforts in the district for that potential. On completion of her PhD, Liz joined the Tech Exploration Group as a geochemist, and her passion for problem solving, geochemistry, and the thrive of exploration was really fostered there. In 2017, she joined the Berwick new North American exploration team, and currently her role encompasses geochemical and geological support for grassroots to advanced exploration stage projects, implementing new techniques for geochemistry, tools, methods, data assessment, and really driving that discovery through technical leadership. And I'll go ahead and let Liz present her mini lecture. And the concept of this is really just to kind of give you a little bit of a taste of the work that she gets to do. So, yep.
Thanks, Maureen. Just taking over here. So, can everybody see?
Yep.
Okay.
Thank you.
So firstly, thank you very much for letting me do this today. It's quite an exciting topic and close to my passion, so really excited to share some things. The other thing I want to just say is this is a huge topic, and I'm not going to do it justice in the short time that we have together. So if there's any questions or further discussions, I'm very happy to continue this conversation. So my talk today is really looking about kind of the evolution of exploration technology and its uses, going through some applications, and then a look to the future. And then I'll end with a little bit more about my career. So in the last kind of evolution of where we've been as explorationists, we've started off leveraging simple tools like hammers, hand lens, compasses, and now we're moving towards much more data rich and really intense kind of environments. And this is a good example where we've got a Leapfrog 3D geological model with AI generated geology on the inner tube that was generated from hyperspectral core scanning information, of which here is an example in the shortwave infrared, just highlighting where we've got alteration changes. And then we've got gold fire assay data coming down as well. So one of the key questions is, why have we gone from simplicity to kind of really data rich and complex ways of looking at data? Is, well, why? There's a really good paper that kind of talks about 3 different things. So one is cover. As explorationists, we are continuing to try and find deposits under cover. And so how do we see through cover, particularly post-mineral cover, when we've just got access to boots on the ground? And that's where technology has definitely helped us kind of see to depth in the crust to identify what the economic potential is. Second, developments of pushing technology is economic efficiency. And what I mean by this is things like cost reductions, automations. The core scanning is a really good example of that, where we can get a huge amount of information really, really quickly, and just helping us to derive greater ore body knowledge at a rapid rate. And finally, data which is not obtainable by conventional methods. Geophysics and geochemistry are examples of those. When we've got boots on the ground, we're out leveraging our hammers in the field, we cannot identify the chemistry of the sample. So that's why those have been developed. So in terms of technology and kind of looking at how we use it in our field, I think it's really important to recognize the people that have come before us. And there's some really instrumental people that have invented some incredibly useful tools that get shared and utilized even today. And there's one person that I really wanted to highlight in this talk, and that's Tony Barringer. And he was really instrumental in the 1960s and the 1970s developing technology. He was probably most famous developing that geophysics EM airborne surveys, which have been instrumental in discoveries for decades. But he's also an inventor for analytical equipment, geochemistry. He's a really interesting gentleman. And I think if you are really interested in understanding kind of the evolution of technology, he's a really good person to look at. But I think to apply technology, you either have to be one or the other or both of being an inventor or an innovator. And the difference being, inventor creates the solution, an innovator will take something that's already created and then maybe retweak it and rebrand it and apply it to a different situation. And we'll talk about that a little bit more in the talk as we go along. So I just wanted to share a couple of examples that I've been involved in. Again, this is really grazing the surface, and if there's any in-depth questions, feel free to reach out. So to start with, this is an example of a hyperspectral campaign from Nevada Carlin deposit. On the left, we've just got the core photos, and then we've got the hyperspectral data. So we've got 3 columns that were generated by the long wave infrared or thermal infrared. And then on the far right, we've got a column that's generated from the shortwave infrared. One of the challenges of Carlin systems is we have quite dark host rocks. So the shortwave infrared isn't as reflective, and so we do get quite limited information. So when we applied this, we were really interested in the potential of the long wave for us to see the alteration, and that's exactly what's coming out here in this example. So we've got mineralized zones that are accompanied with decalcification, and then in silicification with manganese-rich calcite on the halos of those ore zones. So this is an example from Jamie Wilkinson and others. It's a pretty old publication now, but it's here to highlight the potential of mineral chemistry. And this deserves a whole kind of speech in its own right. But in terms of advances of chemistry, mineral chemistry is really up there as a tool that's going to be really beneficial, I think, in terms of exploration and just ore body knowledge. So that's one to come. This is an example of drones. I had the privilege of being with one of our geologists in the field a couple of weeks ago, and he was flying a drone, and it was incredible how quickly we were getting aerial pictures of super high quality of outcrops that then we could go back and interpret and analyze, as well as having that boots on the ground kind of view as well. We had this aerial view to help us with our mapping. And they can be used for geophysical surveys as well. And I think there's a lot of options to do with pit stability mapping and wall pit mapping as well with drones. So this is just a handheld XRF, but it's here to kind of signify the whole swath of handheld analytical tools that are out in the market right now. A portable XRF is just one tool that gives rapid chemistry, but you also have portable XRDs to give mineralogy, SWIR detectors, again, to give mineralogy, or LIBS systems, which is a laser-induced breakdown spectroscopy. So as we are pushing into environments like grassroots environments, the need for rapid data is really important. And that those handheld tools have been really critical in helping us tap that real-time data. There's a lot of publications out there that give examples of field seasons where people have completed rock surveys or soil grids and leveraging a PXRF to be really successful at identifying targets in a much more rapid manner, so exploration companies can act on it extremely more rapidly. In the terms of geophysics, one of the most exciting developments recently is there's a moving away from proprietary code that's been established at academic institutions to more open-based communities that are sharing codes. And we have a company have tapped into that, and it's quite impressive about how much that pulling from the community has really enhanced code and what we can do with geochemical and geophysical models. And finally, I wanted to just share, without drilling, exploration doesn't exist. And we had the privilege of working with this little rig during the summer on one of our exploration programs. And it was a very exciting and ambitious program. And I think the development of this particular rig was definitely helpful in driving getting that quality sample. So this is just a really short kind of snapshot of technologies. There's other things that we could discuss, for example, downhole structural analysis. There's a whole range of developments in terms of analytical capabilities at labs, like photon assay, isotopes, geochronology. We are truly in an environment now where we can analyze anything we want and really help us to drive and get greater detail on ore body knowledge, which is really critical from an exploration point of view, just understanding the potential of the geology and also the potential of the mineralizing system. So where to next? I think it's really important that we as an industry keep tabs on our peers, our closest peer being the oil and gas industry. They've got deeper pockets, so they develop things slightly quicker than we do in terms of technology. But they are developing drilling technology, of which one is here. It's a coil tube kind of rig to help drill and collect those samples. I think the medical industry and other industries I've listed here potentially have impacts. Just one of them is this automated petrographic scanner. This was developed with the medical industry in mind, not mining, but it's completely applicable to geology. I think the other thing that we need to do is make sure we understand what's missing from the technology that we have right now, but be free-flowing when we have the chance to use what we can use to push the developers and push those creators to apply more or answer more specific questions. So for example, in core scanning technology, could we leverage core photos with textural identifications and add that layer to chemistry and hyperspectral scanning to give us an even more robust AI outcome? The other thing I think is important as we are as an industry, and it's one of the privileges of my job, is I get to work back and forth with the companies that we partner with in terms of technology. And so quite often we have we review the data, and then we have a free-flowing conversation of what's working and what's not working, and kind of what we would like to see develop as a tool. And so the final thing I wanted to share with everyone, because I'm presuming people are early in their career, is don't be afraid of technology. What leads discovery is geology, and leveraging the geology. So I don't think technology is ever going to replace a good geologist. And so it's really important to understand those fundamentals, you know, IDing rocks, IDing minerals, being able to map, being able to do section work. There is power still in doing pencil and paper sections. It forces you to think and reimagine the geology in a different way that a computer program would do. So even though technology is expanding and getting more powerful and allowing us to detect and analyze and understand more, we're still going to need good quality geologists in order to make economic discoveries. So never be afraid of technology, embrace it, but fully integrate it into the geology, and keep thinking like a geologist and being a geologist at heart. So like I said at the start, I would not do this justice. So I wanted to share a couple of good resources. I think Anne Thompson's Ore Deposits Hub YouTube talk is really good. So if people want to look at this more in depth, there's a lot of resources out there that talk about the evolution of technology and its current examples in the industry. So like for my introduction, a lot of this was already said, but I just wanted to focus on a few things that I've been doing with Barrick since my time here. My role is the principal geoscientist, for the North American group, and it's my job to support the team in leveraging data, particularly leveraging geochemistry in terms of its application, interpretation, data collection, and data management. So some of the things that I've been involved in is we've done a couple of hyperspectral core scanning trials at several of our sites. Developing that has been great fun, and seeing what we can do to push detections and adding in AI interpretations to those layers. Working up data for soil grids, again, trying to do simple things like mapping the bedrock geology from our soils. That's always a fun thing to work on. In terms of technology, I manage the handheld instrument fleet and their application to help us ID rocks and alteration and mineralization zones as we are doing that real-time drilling or data collection in the field. But if anyone has any more questions, just feel free to reach out. But thank you very much for this, and I'm going to pass back over now to the next speaker, I think is Steph.
Oh, actually, Jesse.
Sorry, my bad.
No, you're good. Well, thanks so much, Liz. I love the concept of the innovator versus inventor. I feel like that'll be something that we can chat about in the discussion period, as it really does apply to our industry. And I love the concept of purposely kind of leaning into one or the other, or leveraging both when appropriate. So next up, we have Jesse Clark, who works with Barrick and Nevada Gold Mines. He has worked in various roles in mining, resource, and exploration over the past 8 years, has been focusing on the collaborative approaches of really discovering value in complex provenances and accurately and characterizing risk associated with the resource and uncertainty. He received his bachelor's from the University of Adelaide in 2014 and a master's in economic geology from the National Master's Program based in the University of Tasmania in Codes in 2019. He's worked in his career at places such as BHP in 2015 within the global graduate program, where he's done roles where he's been a principal geoscientist at BHP Olympic Dam operations, and is now currently a mineral resource manager within Barrick Gold. His focus is to support Nevada Gold Mines to create long-term value by underpinning business development and operational opportunities with world-class geologic models. He's a passionate member of the Society of Economic Geologists and is served on many committees, as well as an active member. So Jesse, you can take it from here. And you are joining us from Australia. So thank you. Thank you for getting up early with all of our other attendees as well.
No worries. Thank you, Maureen.
Yep.
Let's just get this screen shared. Okay, cool. So my talk's going to be rather complementary to Liz, but instead of an exploration twist, it's going to have more of a production flavor. And a little bit biased, but my background has been working in quite mature districts on lots of different tier 1 and 2 deposits. So I wanted to pull out some main themes from those districts. Let's just get in here. So I think it's always interesting when, I mean, there's 3 of us presenting today and we're all got very different backgrounds, but our philosophy, it turns out to be quite similar. So I always like that independent connection there, but I am fully on the page with Liz here that innovation is really working on other people's invention and rebranding it and evolving it. And when I think of technology, it really comes down to people disrupt and technology enables that disruption. And for me, there's no one better than Steve Jobs who embodies that. And I've always enjoyed this quote, which is, don't be trapped by dogma, which is the results, living with the results of other people's thinking. And so in mature districts, especially mature tier 1 districts, there may not have been a significant discovery in several decades. And this can be a factor of many different things, but what we see over several decades is really just incremental addition or conversion of ore reserves, which basically keeps the life of mine fairly consistent throughout those periods. But what I always like to think about in these mature districts is we understand that the value creation is on this uptick of this S curve, which is when you take a discovery into development. But in these mature districts, we're typically working on deposits that have reached this production peak and have now continuously started to subside or plateau in terms of their value. So this is a bit of a different twang here, but we can utilize existing technology and innovate those technologies and push some of the barriers that are in our little box in some of these mature districts, and really start focusing on how do we find the highest quality ore reserves, because this is how we actually lift that value curve once you're in mature production profile. And in my point of view, this really comes down to 2 things, which is geological driven growth, real growth, but also good ore body knowledge in terms of risk characterization. So do we truly understand the uncertainties and risk from a geometallurgical, geotechnical, geoscientific standpoint of these ore reserves that we're bringing into production? And this is where it comes down to quality. But these mature districts come with many challenges. They are typically extremely data dense environments. It's a flip of a coin from early stage exploration where you may have a dozen holes, if you're lucky, through to scoping studies or pre-feasibility studies where you may have a few hundred holes. But either way, during that period of 1 to 3 years of those stages, there is adequate time to really think about and do good ore body characterization on those drill holes. When you enter a mature district that has 40, 50, 60 years of highly variable drilling data, what you typically see in a 3-dimensional aspect is huge inconsistencies in the data inputs. And this really feeds into the second point here of entrenched thinking. Usually what you can see is when you open up a raw logging code and you see 160 different rock type fields, you can start to track the trail of model-driven thinking and how that's progressed over the decades in these mature environments. And it's particularly complicated when you're in the tier 1 district and you have multiple tier 1 assets. So we're talking tens of thousands of drill holes. So this is a huge challenge, and it's a bit like a spaghetti factory, and it's very off-putting to a lot of geologists, and you don't really know where to begin. And so I will give you 2 case studies of how technology can help us with that. But the third biggest challenge with these mature districts is we become so focused on capturing data at the wrong scales. And so we're thinking and looking at hand sample to outcrop scales. So that is essentially high wall mapping, underground face mapping, or development drive mapping to core logging. But a huge gap is spending the time critically thinking about the geology beyond that one-dimensional point scale. And we're very good as geologists at looking at that point scale and going, I need to capture 160 different observations that I can see in this one stick of core. And it's all very purposeful and great, but we need to step back in these mature deposits where it's possibly tens of thousands of drill holes at the deposit scale and take an outside-in direction of prediction. And so Jun Cowan had a good paper, and I fully agree with that. This is the philosophy that I've always stuck with, but you can get so much out of your drilling data and your geochemical data that it helps inform how you should be looking at your hand sample and outcrop information. And so what I challenge here is we have a lot of time spent looking at process and what I call busy work in these production environments, especially when it's a high volume production environment. There's a lot of perceived pressure to react to daily or weekly variance, and it is value destructive. And what we need to do is really pivot this table and start really critically thinking about the geology. And what we see is as we increase our time doing all these other tasks that we justify and rationalize every day, we are actually diluting how much geology we're actually thinking and doing. But the complicating factor of technology is that it can be a diluting trap, because we can use it as a guide to say, no, we are looking at geology, we are producing geological models, and we are getting all this data into one of our software packages. But the way we've captured that data, look at that data, think about that data, and organize that data on the computer screen is something that we've always done. It's not really pushing the paradigm in thinking. And are we actually adding value? And so this is the sort of philosophical trap of technology I wanted to disclaim in this, and consistently talk about pushing back this scale. So we're thinking about geology. And I guess when you look at a great period of mining geology, which was the 1960s, you had a lot of really excellent discovery, but also development of really world-class mines and world-class processes. And a lot of those processes we've carried on to today in terms of how we capture data. A good example is Anaconda mapping method. And when you look back, they were simply critically thinking about the geology and what was the mineral controlling factors at their sites, at their deposits, and making systems and processes that very efficiently gleaned the maximum value out of that data into a very simple format that we can consistently produce updated interpretations. And so I think technology has complicated a lot of this. And one key case study that I wanted to discuss is a really huge disconnect is between the way we capture data and do our designs. So take that data and put it directly into designs, which could be for any mine plans or drill plans. And we have this huge disconnect, this really long gap between the resultant interpretation and 3D geological model and resource model I'll tuck in there. And one really excellent way to utilize technology is to break that gap by streamlining and understanding all of the individual workflows in your value chain. And the whole goal of this is to take a holistic viewpoint and really target, okay, interpretation and modeling is where the high value adding work is. So how do we streamline these processes to give us more time to do this? How do we get our geologists working underground in a production environment to actually focus more on critically thinking about geology, taking away those daily production pressures, which are usually quite perceived, not real, and beyond our control and influence on actually making any meaningful value add there. And so one way to do this is to centralize your data management. What typically already exists in most organizations today, hopefully, is that we have a SQL-based database, and that's really excellent. But what does the data management look like? When was it last reviewed? Was it set up 20, 30 years ago? And is it bringing in data and outputting data, the right data looking at the right quality of data, and does it make sense? Is it convoluted? Is it simple? But beyond that, we can look at each silo of our value chain, which is from mapping, which usually is not a standardized process, to bringing that into a semi-automated standardized workflow, which a lot of software programs can do now, and utilizing as much new information as we can get, high resolution face photos or high wall photos, direct to tablet, especially if you have Wi-Fi, direct mapping directly into those tablets, but stepping back again to go, what is the actual key inputs that add the most value without biasing that subset of data? And consistently building a workflow that makes a geologist step back to look at the broader 2 dimensions and 3 dimensions in and out around where they're capturing data. And a good example with mapping is, in a course of 12 months, you may have 12 different geologists mapping a whole bunch of different areas of your mine. And it may not necessarily be in a routine fashion of advancement. It could be quite random. And it could be 6 back-to-back geologists, and we have 30% attrition rate, which is not all too strange in the last few years. So if you don't have a good standardized system and workflow, that one takes the repetitive process and automates that as much as you can. And 2, has a clean data management, so we're all understanding what we're mapping. We don't have one geologist thinking that folding is the most important local mineral control. I'm going to focus 90% of my time and attention on that, versus the back-to-back geologist thinking, you know what, geotech is the biggest risk and concern. I'm going to capture mostly geophysical data and subside on how much I'm looking at folding and structural information that's to the geology. So this is a really important thing to have in place on every single part of the workflow. And really the whole point there is to drive ore body knowledge through 3D interpretation. So we want to spend the majority of our time thinking and producing modelable, usable products for our stakeholders to use and have that ore body knowledge recognized, and eventually within our resource models. And so it's all about shrinking how much variation we have in our processes, how repeatable they are, and can anyone across that district go anywhere and basically pick up the same process and not have to retrain, relearn, and redo completely the same role, but completely differently. But it's also thinking about what is the most valuable components. And so this is where plans are nothing, planning is everything. And this is where technology has really come a long way and can really help us drive that innovation. And then the second one I wanted to talk about was implicit modeling workflows. So this has probably been the most disruptive technology aspect of geology in the last 20 years. And in the last 5 to 10 years, it's become increasingly important among most companies, where we now have geological modeling teams, and pretty much every single project and mine in the world is producing some form of implicit modeling now. And it really comes back to, in these mature environments and these data dense environments, if we don't have systems and processes set up to capture the right data at the right quality at the right scale, then it's garbage in, garbage out to any model. But the thing that we've lost in the implicit innovation is we can rapidly produce lots of different geological models, which is really excellent, but we don't utilize that as well as we should. The speed and power of the radial basis function algorithm, that is the implicit modeling softwares, is that we should be able to produce multiple hypotheses to explain the geometries that we're seeing and explain the mineral controls we're seeing. We should be able to produce multiple different geological models to test those hypotheses as we go through a drilling phase. But typically what happens is we have one implicit model, we focus just on the raw data inputs. And what we've lost through time is this explicit control on our implicit models. And so while explicit modeling is really slow, it's very painful, and it's highly subjective. So it's not, it doesn't have the precision, the repeatability, but it is usually accurate. It has considered most of those geological controls that is understood at the time. Whereas in implicit modeling, if we take the raw data, especially if it's 50, 60 plus years of data, and it may not be necessarily consistent in 3 dimensions, we may lose a lot of the accuracy of what we understand today about the ore body versus what has been captured over several decades of different thinking and involvement. But it's precise, it's repeatable, and it's fast. And so I urge that caution and to constantly think about what we're modeling. And the good thing about implicit models is that they're highly sensitive to data and the explicit controls we put on them. So just one structural data input or trend can significantly alter the shape, geometry, volume of the resultant geological product. And that can have very dire or serious consequences. So it's really important to consistently thinking about the geology. So to conclude here, people disrupt, technology enables. Technology offers solutions to many problems, but it's really up to us as geologists to try and innovate what we actually need solving, and to consistently think back and critically think at the right scale and resolution of your ore deposit to try and work out how do we best get that ore body knowledge into our systems, and we spend that time thinking about the geology so we can get towards longer term prediction rather than shorter term reaction. And so that's the frame of the talk there, and Maureen's already spoken to the career pathway, but I just wanted to add that, and if there are lots of ECP geologists on the call, that I've worked in 2 districts now, so IOCG districts in Australia and the Carlin systems now in Nevada, but I took very literally in my undergrad, those who see the most rocks win. And so since my 2nd year, I've tried to sign up to every single field course that I could possibly have done. And it's led me to 7 or 8 different countries around the world, looking at over 120, 130 deposits now, both active mining or exploration projects. So I'm very fortunate to have seen those, but I've consistently chased looking at new deposits and try to meet as many different geologists as I can, because that diversity of thought and opinion is really important. But I've also spent most of that 10 years being an active SEG member, which I highly encourage everyone to look into, and have served and still serve on multiple committees with the SEG. And so it's really an excellent way to keep in touch and to consistently challenge thinking and ideas and have really great discussions. So on that, I'll hand it back to Maureen.
Thank you. Awesome. Yes, and kind of taking time to reflect. We'll talk more about that in the question and answer, but fantastic summary. Next, we have Stephanie Mills from the Utah Geologic Survey. Stephanie is a senior economic geologist there and has received her bachelor's from the University of Texas, Austin. And then after receiving that degree, she went on for a PhD from Monash University in Australia, and has worked with in several years in a global exploration role before joining this survey in 2019. Her research focuses mostly on magmatic hydrothermal mineral systems and developing field-based exploration techniques. She is also a fellow of the Society of Economic Geologists and a professional geologist, registered professional geologist. So with that, Stephanie, take it away. Thank you.
Okay. So I'm gonna, in the some ways, talk very similarly to what Liz and Jesse just spoke about, but I'm also going to approach this from kind of the direction that I live in these days, which is not having very much budget. So it's really fun to talk about exploration technology But the reality is that a lot of these things do cost quite a bit of money. And kind of as we've detailed so far, one of the defining characteristics of this period of this era of exploration that we're in currently is that there are probably more technology choices and data sets to support minerals exploration than at any other point in history. So we're very much in this era of big data. And, I've just shown on here all sorts of different things. Each one of these is probably its own talk, but just to demonstrate when you're doing exploration, the number of choices that are facing you. And this applies to the technology that we use to collect data, how we store and manage our data, and how the technology essentially that we use to interpret our data. I'm going to, as Liz mentioned, there's absolutely no way to do this justice in just a couple of minutes. So today I'm going to focus on exploration. So I'm going to focus upstream, like greenfields exploration. And I'm going to focus on the technology and data, essentially in the collection interpretation phases. So hopefully this might be comforting to those of you who also don't have a huge budget. More does not equal better, does not always equal better when we're in the data and technology space. Oops. So I would argue, and this is kind of built over years of experience, both in and out of majors and juniors, and then kind of where I am now sitting on the sideline watching everybody, that this plethora of technology and data that we have available to us can kind of lead to these mentalities that I've called either the shiny toy or the FOMO exploration approach. So the shiny toy approach, which is essentially you always want the next new thing, whatever it is that you want to do it and you want to try it, and that doesn't necessarily correlate with whether you're already doing something or if you have any idea how to use something or if it's the right tool for your problem. You want to do it. And FOMO is kind of the same thing, which is fear of missing out, where you're terrified that someone else is going to make a discovery using some cool method that you haven't done. And I think that's especially, whoops, sorry. That's what I get for having my notes on my keyboard. I think that's especially pervasive in the modern exploration culture, where we're very, in some ways, we're very scared of being at fault for not knowing the next cool exploration thing. But I would argue that this mentality is almost in direct opposition to the reality that's on the ground, and both Liz and Jesse have already referred to it. But essentially, we need a deep domain knowledge. So we need to know geology to apply these technology and data. And we have to kind of ask ourselves two questions about any sort of technology or data interpretation, which is one, do I have the domain knowledge to use this appropriately? And do I have the domain knowledge to know if I'm applying this effectively? So I'm going to go through a few examples of these two questions in hopes that this might equip some of you early career geologists to navigate the plethora of technologies available. So the first question is, can I use this appropriately? And I want to emphasize, the question is, can I use this appropriately? So someone surely can use this appropriately, but that person might not be you. So for example, I'm very strongly on the geochemical side of things. If somebody came to me with like this amazing new aeromag something or other that could find any deposit on the planet, that would be fantastic. And I would definitely not be able to use it. So we need to acknowledge sometimes those self-limitations. And we need to make sure that when we ask questions, we're addressing a specific problem and we're not letting a method drive us. So this is a cool method and I just want to use it somehow. So I've got two examples of some fairly common things in industry these days. So a handheld XRF and machine learning. And I've seen over the past, I guess, 10 or 15 years, the early phase when these technologies came out, it was kind of like Silver Bullet or Yukon Cornelius, if any of you are American and know the famous prospector from Rudolph the Red-Nosed Reindeer. We were basically, these methods, our question when we approached them was, how does this find me an ore deposit? And, that's not a real question. That's not a question that's really answerable for any specific piece of technology. And what we've moved to these days with, say, handheld XRF is a much better approach of how do I take the best measurements on this whole rock sample to give me robust data, geochemical data. Or, for example, we're looking more at like how robust is portable XRF able to report on redox sensitive trace elements? And is that going to help me with my lithogeochemistry and reconstructing structurally dismembered domains? So very specific problem-driven questions. And same thing with machine learning, going from kind of like, if I put all of this stuff into it, surely it's going to tell me something cool. And I definitely went through a phase of that myself. So I get it, and I'm not judging anyone. But we're asking much more intelligent questions now. Things like dimensionality reduction, finding anomalies in data. That's kind of on the interpretation side of things, but on the practical side of things, how can machine learning help me log core more consistently? So it's a very specific question, for example. And there's lots of applications to how machine learning can interpret core photos and basically do consistent geotechnical logging, which then frees up a geologist to do more geological interpretation. So can you use it appropriately? Just because it's there doesn't mean you can use it. And make sure that you're addressing a specific question. And the second part of that is, can you apply it effectively? So just because it's there doesn't mean you can use it. That was previous slide. And this slide, just because it's there doesn't mean you should use it. So there's lots of really cool things out there. But especially when you're working on a limited budget, you need to be looking for things that are going to budge the needle on exploration. You need to look for things that are going to make a difference when it comes to making your next drill hole call. So zircon chemistry, porphyry fertility, whole rock porphyry fertility. This is a very popular area of especially research, but certainly in exploration companies as well. This is essentially, it's going to tell you if your intrusive is fertile or infertile for a porphyry. But I would argue and kind of push back a little bit against that for on the ground exploration, because like, what is this telling you? So say you pull some core out of the ground, absolutely dead, but it's fertile. How does that help you make your next exploration decision? Or for example, in the picture with the rock hammer, you run something that comes back as completely infertile, but you can literally see with your eyes that this thing is mineralized or altered. So sometimes we get so caught up in what's really cool or what's really, a new method, but we're not really making that connection onto the actual application and use of it. So one way that maybe this could be useful is if you're doing stream sediments and looking at detrital zircon chemistry. So over a large area, you can see somewhere in this catchment, maybe there's a fertile porphyry. But then the reason that I think that method works is because you're kind of moving to what's called brute force coverage. So when you're on a budget, I'm a big advocate of brute force coverage. So, get your portable XRF and make sure you know how to use it appropriately, you know how to use QA/QC, you know how to take those measurements well, build yourself a robust data set, and just go out and smash your measurements. And I mean, the amount of data and coverage that you're going to get doing that versus say 1 or 2 zircon chemistry analyses, it's going to be much more effective when it comes to making exploration decisions. And this has been an ongoing theme with all of the speakers, but essentially geology dictates everything. So absolutely everything we do needs to be driven by geology. So, the major questions that you can ask yourself is, what are you trying to find and what are the geologic controls? Not only the geologic controls on the type of deposit that you're looking at, but also on the terrain that you're working in. And another way to think about that question is, what will get me to robust drilling stage the quickest? Because in reality, drilling is going to be the best method for exploration. You want to drill intelligently though, and you don't need to go to diamond core right away. Maybe you just want to do a first round of RC drilling, whatever. But either way, what is the early stage exploration technology and data that you need to get yourself a robust drill target? And I think if you ask yourself that and you focus, if you kind of focus on that as a goal, and then obviously you're kind of going to ask this question through iterative processes of drilling, I think that is one of the best ways to guide a very focused and efficient exploration campaign. Jesse touched a little bit. I was kind of gratified to hear Jesse touch on this idea of technology is great, but sometimes it's also a distraction. And I think particularly when it comes to field work, we need to think about the integration of technology. So I've lived this very recently. I'm working on mapping a 24K quad, and I went out there with my collector, or I don't know, Field Maps app, and on my tablet and started collecting points. And I'm working in a really horribly structurally dismembered district. And what I found as I was working through this is I could not conceptualize the geology. I just was not able to do it because of the way, the collection on a tablet is just not as involved as when you're doing it on, say, clipboard. And what ended up happening is I ended up going out subsequent times, still with my tablet, to collect points, but to actually be interpreting and drawing on my map on my Mylar as I was out there. And I think, it was so fascinating to me that just to even mention anaconda mapping. And I had a conversation with a chief geologist of a big company just like a month ago about this exact thing, about we need to think about how technology has kind of disrupted mapping and geologic interpretation, but not in a good way. It's kind of distracted our brains and maybe helped us to disengage a little bit. And there's nothing wrong with mapping by hand and say snapping a photo and digitizing it that night. So there's still important to get things into a common shared digital framework, but we have to find a way to do this. That means we're not turning off our brains as we go. And one thing I will see, I'm allowed to say these things because I work for a survey. So one thing I'll point out is there's a really big push for like at lab measurements and instantaneous data and this and that. That's good. I've lived that. But you need to ask yourself, why are we doing this? Who is it for? And a lot of times what it's for is it's for a manager to look at every day and monitor what's happening. And so what happens is the geologists that are on site are so frantic trying to QA/QC the data and get it onto some portal so that some manager can basically look at it and be like, did we hit or no? Okay. But no one's actually thinking about the data at any point because geologists on site is scrambling, the manager's busy, they're just basically looking for ore. So we really, we need to think about the pluses and minuses of this instantaneous data collection and think about why are we pushing for it, who are we pushing for it for, and are we truly enabling geology to be integrated as deeply as it should be. And what we want to avoid is creating a geologic nanny state where essentially managers take over interpretation from a distance without being the ones who are actually on the rocks. So this is pretty much it. I've just got a couple takeaways. I would argue that a limited budget, because it forces you to use fewer methods and apply more thought, it's more likely to drive innovative approaches to early exploration because you just have more deep thought time on geology. And echoing what the others have said, this basically implies being a good geologist is not going out of style. Some things that I think could improve in our industry is minerals exploration needs to learn to share. We need to learn to share technology and data and everything because there is so much rework going on. Like every time someone picks up a new project, they're doing the same thing. Logs are being redone again and again. It's a huge time sink. And there are some moves to these like Amira and Kawsaram, some of these research coalitions, but those are still pay to play and they leave out a lot of people. So it can become a bit of an echo chamber because there's only so many people who can pay to play. So it ends up being some of the same people over and over again. So we need to think about ways to do this that is much more inclusive of the entire kind of economic geology community. And I would also argue for a more thoughtful pace of exploration, which essentially is a slower pace of exploration. So I really, having had the career I've had, I really don't advocate these instantaneous data results. I think it kind of feeds into a negative interpretive culture. And also I think like just in general, exploration can't be driven by the quarterly report. In general, we need to find investors and funding opportunities that are understanding of the timeline that's actually involved in exploration and in these very geologically intensive interpretations. And, with that, the geologists need to be doing geology. This is kind of what Jesse was talking about with like process work versus geology work. Like the geologists need to do geology, need to be freed up from all of this busy work to really think. And I think a big part of that is that managers need to empower them and create structures that are encouraging their geologists to really think. So that's it for my talk. I think the introduction from Maureen pretty much covered it for me. So I'm a senior geologist at the at the Utah Geological Survey. I'm also an adjunct at the University of Utah. There you go. That's what I was trying to say. I had all sorts of junior and contract and short-term gigs through most of my education. And so I got a huge variety of experience. Then I worked for worked in exploration full-time, worked for several majors, and then joined the survey. So I've had quite a diverse background. But what's funny is I'm not from Utah. I don't actually have any ties here. But somehow I have been to Bingham Canyon almost every stage of my life. So the top picture is me at like 19, who didn't even know how to wear a hard hat properly in Bingham Canyon. Then there's me in like my late 20s, super cool, like industry lady. And then the bottom pictures from earlier this year where cool doesn't even factor into my language anymore. I'm just there with like my 2 kids, dragging them along to go look at the mine. So yeah, that's pretty much it for me.
Thank you, Stephanie. It's so great to see everyone's not only career, but also the connections and the concepts that we're covering here. It's fun for me who got to pick all of the people and without really understanding how they would all tie into play. And so it's fun to actually see everything in the results. And so now what we'll do is we're going to go ahead and switch over to the question and answer discussion period. So we'll take a couple of moments to fill out the questions that you might already have. And it looks like we do have a few here. So let's see. We have one that was answered, but I think it would be good for all of the panelists to take a moment and review. What is better in your personal opinion? To have the exact geologist mapping only one area, or to have a variety of geologists map a certain area? So Liz, thanks so much for adding your thought there. Jesse or Steph, would you like to contribute?
So it all depends on what you're mapping. Oh, sorry, yeah. Steph, you can go. Yeah, it all depends on what you're mapping and what scale you're mapping it at. So if you're in a production environment, it's never going to be one person mapping it, and nor should it be. But the risk you run into is if you don't have a good mapping structure or good training so the geologists know what they should be mapping, there's so many different ways you can deviate that course of data capture and focus on so many different things that at the end of the day do not consistently make sense in 3 dimensions. And that's the ultimate goal, right? Is you want to use this data towards something. We're not just capturing it for the sake of capturing it. It needs to be going towards something that's going to be usable, whether it's for a predictive growth strategy and or whatever you need to use in your production environment from a production point of view. It needs to be usable data, so it has to be consistent. So it shouldn't make a difference if it's 1 or 12 people mapping the same area. The interpretation may be different, but the data capture should be the same, or at least consistent in quality.
Yeah, I reckon that's really well said, actually. And it's interesting that mapping came up in the questions and in so many of the talks, because I think it really is, I think several people in industry and even me in the survey, like we're noticing we had that era of anaconda mapping. It was just so robust and, everyone knew how to do it. And so for a long time, this was just built into the DNA of exploration geologists, but now it's not getting taught anymore, and companies don't really have those systems built in the same way. And so, yeah, I actually think a lot of people are trying to work out how to do that exactly the way Jesse described. And I don't think it should ever be one person. I mean, you want to have multiple eyes. Geology is science. We're here to disagree. We're here to rigorously test ideas. So it's important that ideas be challenged. And so another thing for companies and managers to focus on, and for early careers to look for in employers environments that really embrace geologic conversation across all hierarchy levels.
Well said, well said. Our next question is from Abeni. Has AI or similar technology been successfully implemented for drill hole logging, where the results of the AI has been at least 90% accurate, verified by geologists? I'm hearing this for the last 6 or 7 years, and I'm not sure if this is yet matured. So I'm not sure if, I know some of this stuff may be internal knowledge, but have any of you had success with that methodology?
Yeah, I'm going to go first and jump in. So we have looked into this. It all comes down to the training data set and how robust that training data set is. Obviously how complicated geology is as well. But to Jesse's point, right, garbage in, garbage out, the better quality you can put into power that AI, the better the output is going to be, for sure. It just really depends on the project. But from my experience, it can be very good as long as you feed that training data set as best as you possibly can.
And
I think it's also important.
one last thing to say. So
no, go ahead, Jesse. Oh, sorry, you might have
just
frozen.
gone unstable. So I didn't catch exactly what Liz and Stephanie said.
Oh, Steph, do you want to go first? Then I can get Jesse caught up.
Sure. Yeah, I was just going to say, I think it's also important to, like, when we say logging core, I mean, that there's a lot of things that could be meant in that. So there's geotechnical logging, there's geochemical logging, there's lithology logging, there's alteration logging, mineralogy logging, you know, there's a lot of stages. So, I mean, I'd be shocked if any AI had managed to do all of those things in one go with 90% accuracy, but I'm sure some of them are getting more focus and more success than others.
Awesome. So next question is, do we have to be in need to develop the new methods, or can this be done through joint development of industry and academia? What are the expectations from academia, new methods for efficient exploration, mine operations, or boots on the ground students becoming geologists? So it's kind of sounds like which ones are important, and should we be working together more in industry and academia?
Who wants to go first? Should I? I think this is a very dense question. Yes, there should be definitely more collaboration. I think invention, what's the phrase? Necessity is a driver of invention. Sometimes, you know, you come across something where you're like, gosh, I really need, you know, gold down into the PPT levels. What, you know, is that commercially available? Or, not really. And so, you know, there's scenarios like that where needs arise from just doing exploration or working. I mean, academia definitely moves at a different pace from industry, but I think it's really important that industry injects questions into the academic realm, and there should be more synergies. Yeah.
Yeah, and agreed. I think the biggest one is, yeah, like it's an absolute yes, of course, but there has to be understanding on both sides of, I would say, like timeline being the main one. And everyone always says industry and academia. Don't forget, government is here too. We try too, but we work on a similar timeline to academia. We're really slow. So I think sometimes this has to do with judging your projects well and judging things that are not as time sensitive to, say, production, but overall can contribute to a robust ore body knowledge. And I think sometimes finding that balance as ways to bring academia in can be good. You know, there is that disconnect sometimes with academia understanding how it feels to have to put a drill rig in the ground. And so I think that's where sometimes we need to make sure we're still doing science for the sake of science. That's important, but there needs to be that balance and spending dollars across the board and things that might actually make a difference for a discovery. So I worked in mineral chemistry for quite a long time, so I worked with a lot of these academic developed methods. So I've seen this play out in a number of spheres, I guess.
Yeah, and if I can chime in too, in my space, I get to actually help with industry, academia, and government. And it's actually fun being kind of the one person that, or one of many people that probably can work amongst the different groups and stuff. And I think if we're able to consolidate what we're trying to do, even within companies too. I think it would be really helpful, as well as just continually mentoring the generation now, or even early career professionals or professionals that have been in there for a while, right? I feel like we can, as even part of this webinar series, we can mentor each other as well. Great. So the next question. Yes, yeah. So more of a statement. Yep, they are working together. There's lots of good examples of that. We just need to do more collaborations, and also probably have some efficiencies to discuss, right? And setting expectations. If we're working on certain things, maybe some groups will need to go a little faster or slow down too. So good points there.
I think,
Yeah,
can I
go ahead.
add one more point to that?
Sure.
I think from the way I answered it from a very industry perspective, which is like, academia and government do something useful for industry. But I also, where I sit, I hear everyone complaining about not having enough talent. But I also see industry completely forsaking any responsibility towards training the next generation of geologists. So sometimes there might just need to be collaborations where it's like, yeah, this student project might not change the needle on exploration, but it's also training a student who might become an exploration geologist who might make the next discovery. So there actually needs to be that balance and that sense of responsibility from industry as well for developing our next generation. So yeah, I just had that thought as I was sitting there.
Awesome. And Jesse, to get you back up to speed. Yeah.
Thank you.
Yeah, no worries. So what we're talking about is we obviously know that academia, industry, government agencies, even technology companies kind of all need to work together to collaborate to help push the solutions to help geologists be geologists more. But we're just kind of talking more about what can we do in that space, or if you've had any experience either in that space.
Okay, great question. And, there's so much that industry needs to do more. Just like Steph's point towards the end of a talk about Amira projects, how they're pretty self-fulfilling prophecies with the same companies just repeating every year and year and year. So that's not really necessarily the best industry approach, in my opinion, either. So things we need to look at is, when industries do get involved and they try to innovate things, they're really just looking at, okay, we map all these data points. How can we do it faster? Because that's going to save us time and money. But we're not really thinking about, well, what are we trying to use that data for? And it's really up to geologists.
Yeah, and understanding that is going to be really important. And we can keep saying all these things that we can do, and the cool part is we're all here to help that next generation understand how best to do that too. So on that note, I do kind of want to take a little bit of a pivot and talk more about what are some of the skills that we can actually help the next generation or the current generation do to focus on, so that we can make more time to be geologists and take the time we need to reflect on the good data we're collecting, and really take a minute to reflect on the interpretations and question ourselves or each other too. Does anyone have any suggestions for the attendees to kind of make a difference on a daily basis, even? Because some of the stuff we're talking about is more. Yeah.
I'll continue that final point I had.
Okay, sorry.
Because,
yep.
Sorry to be so disruptive.
That's okay. That's what we're here for, right?
Getting at, that's right. What I was getting at was, one good way to think about it is like a pharmaceutical company approach, which is all centered around research and development and what the return on investment is. And so what I challenge geologists to do, which hopefully will push their management teams into thinking a little bit differently, is when it comes to data capture and process control, it's really easy to work out how much time you save on a certain process, and then you can link that back to cost saving. But what about ore body knowledge? How do we quantify ore body knowledge so it's actually a value addition to the company? And because it's not a real dollar cost on a balance sheet, it's really difficult to do that quantification. So we have to be more creative in how we think about what is this ore body knowledge we're generating, and how does it directly or indirectly result in the value. And so good things to do is, if you go through a mapping process change where you're trying to drive, actually 50% of the time, you just should be thinking about what you're mapping, linking that back to a 2D and a 3D interpretation, even if it's just lines that you give to a modeling geologist so they have that extra context, because you're the people at the grassroots, you're the people at the coalface mapping that data. You can see it, what it looks like in 3D. And modeling geologists may be at the computer screen just relying on your data input. So you can come up with a way to bridge that gap and justify it, but then quantify it, taking what are some of the geotechnical inputs you can get from that interpretation into a new and better geotech model, and start to quantify value and think of it differently like that. Then you can start to put numbers to this ore body knowledge component. And that, hopefully, in my experience, has always led managers who are either on board or not on board. At the end of the day, once they see that value addition in numbers, they tend to think a little bit more differently. And so it's really on us to help drive that.
Yeah, great point. Yep. And in there too, we'll put my question to aside right now, because we do have a few more coming into the group. If there's any specific to you, feel free to answer the questions there. But this one we'll talk as a group. Which do you think are the most promising technologies for greenfields exploration undercover? Is there any particularly in dense forest terrains? Is there any technologies that anyone from the panel has really thought is promising, whether it's brand new technology or maybe underutilized? So again, thinking for brand new things versus innovating a older solution too.
So it depends a lot on what you're looking for. So there's a variety of ways that you could probably answer this question. Maria, do you mind kind of typing a little bit more, just to help us answer that more effectively? I mean, geophysics come to mind, but there's also a range of technologies, right, that could to do with sampling that we could talk about, handheld instruments.
Yeah, I mean, I was going to say sometimes drone imagery to help you just locate any outcrops, so that if you have outcrop, I mean, that's not always going to, I don't know. I live in the basin and range, so there's not forest here. So I don't know how densely forested it is, but anything that can help you to locate actual outcrop, I think, is always going to be an advantage of hyperspectral things like that.
Just to add to Steph's point there, now that I'm in the basin and range, I fully love that there's outcrop everywhere. Coming from Australia, where you're in buried cratons, the key thing though is you look at decades of evolving technology, and has it actually assisted in that many greenfield discoveries? And that's an argument we can have, but I think it's really important to Liz's point, is that it really depends on what you're looking for, and do you understand the mineral system dynamics enough? Do you have an essential ingredient list that you're trying to predict and detect? Because that's going to absolutely determine what technology you use to try and predict and detect those things. And if you don't have the right calibration, technology is not going to help you.
Yeah, so asking those questions, and it looks like Maria was asking specifically to apply to magmatic hydrothermal systems. So hopefully I think that might have answered, and it sounds like we have some more additional contributions for that question too. About geophysics handheld has been helping discoveries and mapping to extent in Brazil, where you would have some of those. So thank you for that.
Another good application.
Yeah.
Oh, sorry, I was just going to say another good application, especially in magmatic hydrothermal, because when you think about that, it's usually a really big alteration footprint, even if you're in a dense forest or wherever. But one good thing, I know Neil Pendock, he's done a lot of work on looking at different satellite detection limits that you can use. So remote sensing applications. and to really try and pull out the sensitivities of the wavelengths to find the different mineralogy and what that may be reflected in your alteration profile, to try and help you shrink that target down as much as you can. So again, it's just understanding that that footprint is 100, potentially 100 times larger than the actual deposit you're trying to target, and utilizing those ways to shrink that target criteria.
I mean, I'm presuming the question is around initial detection, like and screening of a property. That's how I would interpret the phrase grassroots. Drone, to Steph's point about searching for outcrop, drone mapping, LiDAR surveys, getting an understanding of that superficial environment can help you then target what the best sample, the geochemical sample to take. Those are kind of things that are coming to mind, but to Jesse's point, you're likely looking for a big signature. So you just need to do a geochemical kind of screen, collect the right sample, biogeochemistry, think about what would be helpful, but many roads lead to Rome.
And I'm on the same bias with Liz. I think it's all down to the geochemistry in magmatic hydrothermal systems.
Yeah.
To really help you understand that zonation and understand where it is and where you are in the system and in the surface environment, and what's preserved. But geochemistry is your best friend.
Going back to that fundamental geology skills, right? So on that, maybe I can ask each one of the panelists to share with us, if they had some advice for the attendees or people listening to this in the future. What can they be doing? Obviously, we keep talking about being a good geologist and learning how to ask the right questions, empower yourself and others to question what you're doing. What kind of advice can you give the future of economic geologists to become those people?
Yeah, I was going to actually mention something, almost an add-on from what Jesse said. So he mentioned, and I've definitely said this myself before, like the best geologist is the one who's seen the most rocks. If you are able and you have the opportunity to go in the field, if your abilities and your lifestyle allows that, do it for sure. If you're able to get in the field, that's great. That is not the case for everyone. And if you can't do it, you can look for substitution. So a lot of major companies actually bring their core back to a metropolitan center for logging. So like Freeport, Rio, to a certain extent, they actually log the core in a city. So, if you have life constraints or can't be out in the field as much, looking for maybe a job that has you in a core shed so that you're still seeing a lot of rocks, that could be a good substitution there. Or, if that's really just not possible for you, what I found interesting about Jesse, he was talking about all the absorption spectra of hyperspectral. So like there are many of these technologies that we use that require a phenomenal amount of knowledge to really use them well. And there's very few people who are able to do that. So there are niches, they're harder to find, but there are niches for subject matter experts in some of these things. Like hyperspectral was the one I was going to use as an example. So, really looking at methods of, say, remote sensing, looking at some of this 3D modeling, becoming a really good modeler, even things like data management and storage and innovative ways of managing that. Those can all be ways for people to look into if they're not able to get into the field. But I do feel like the easiest answer to this is see as many rocks as you can, go on field trips, listen to seminars, things like that.
And to add on to, oh, sorry.
Yeah, no, go, Maureen. No,
yeah,
you go.
Okay, cool. Yeah, so to add on that, I was just going to say, I don't know how many of us have attended like the SCG ones, right? So SCG has sponsored ones. I work a lot with universities that are working with students that maybe are not able physically to go into the field. And so there are nowadays with the everyone pushing remote options, there's way more ways to look at rocks than just holding it in your hand. Obviously that's the best. But if you are on a budget or are not physically able to go into there, there's lots of options for you to keep plugging away too. Jesse, go ahead. Hopefully I didn't cut into it.
So the few comments I wanted to add, and this is again, I'm coming from a production environment, but Hugh McKinstry said it really well in 1948 book on mining geology. It's the geologist is the custodian of the ore body. And so what I implore you all to do is really know your data, really dig into what is there. And for the most part, no matter where you are in the world, there is typically decades of data, all the way from your geological survey scales, which is very coarse potentially, but all the way down to just the few drill holes that may have been drilled around your property or inside your property. Really understand the data. Your role may have a description, but you as a geologist have a duty, and that is to own that ore body. And I can't implore it enough. It's up to you and no one else that you really take a deep dive into the data. And there's so many resources. There's tons of SEG webinars, and the whole SEG store has all the special publications. They're all so useful. But even things like Scott Halley, he puts a lot of free geochemical workflows out just to help you try to play with the data and test the data. And you can do it in spreadsheet exercises. You don't have to have fancy software like I guess, but it helps. But that's just what I encourage you to do, is really understand your data and try to look at the patterns. Forget about the models, forget about what people tell you to only look at in an insular sort of way. Really just look at everything. And the more data dense environment you have, i.e. if you're in a production environment, then hopefully the more the data tells you about your ore body than what you probably know about it. And just question it. Look at it, question it, go and ask questions, find the right people to ask more questions. And if they don't have the answer, I've never really run into a geologist who is an SME who didn't want to help someone. So try to utilize the network as much as possible.
Fantastic. And if you don't have a network,
SEG.
I can't volunteer. You can volunteer. I'm not volunteering everyone else, but feel free to connect with me, and I'm always happy to hear what you're about and try to make connections. I may not be the person you're looking for, but I have a lot of friends. So
yeah, shameless plug. SEG has a mentoring program, and there's about 70 active mentors, and I'm one of them. But there are tons, and they all give you what their backgrounds are. It's industry, it's academic, it's government, what their research interests are, why they wanted to be a mentor. But there is such an excellent, again, if you just ask, typically there are lots of people there willing to help answer a question in or outside of your company or work, wherever you work. And I encourage it. I encourage you to get away from your insular environment and ask lots of questions to other people with different opinions and experience.
At all levels, right? I feel like the more you learn, the more you realize you don't know, right? So I know that many of the mentors on there, they're peer mentors for subjects, right? So how about you, Liz?
100%. It's like the biggest misnomer. Right.
Yeah. I think just piggybacking on what Steph and Jesse have said, so I'm one of these people that hasn't had a privilege of visiting 125 different mines. I've seen a lot, but not that many. For me, I read a lot. Tapping into the SEG has definitely been really good for me. I think particularly as a young geologist, it exposed me to deposits that I would never have the opportunity to go and see kind of live, but kind of tapping into that great network of geologists and academics. Reading those papers that are devoted to kind of sharing their ore body descriptions and geological descriptions rather than more academic studies really helped me as a young geologist kind of understand economic geology and give me a broader understanding of ore deposits in general. Don't be afraid to listen to people. I love interacting with students because you guys think so differently to me, and you don't have the biases that I have now that I've probably in my mid-career, and you think in different ways. And I remember interacting with a student a couple of summers ago, and they talked about drilling a target in a completely different way, and we're like, gosh, that's brilliant. So don't think you've got nothing to share. Everyone definitely has, and I truly believe that we can all learn from each other. And the final thing I would say, as I am an explorationist, be comfortable with being wrong, but don't let that ever perturb you from keeping to try. Okay, so one of the great things about being an explorationist is we get to reimagine the geology. We stick holes in the ground. We don't always hit what we want to hit, but we get to be very very good at kind of reimagining and reinterpreting geology. So get comfortable with doing that. Strengthen your foundations as a geologist, and don't be afraid to be wrong, because you can learn so much from being wrong as well as being right. It's not a bad thing.
Well said.
And I would just say now is in some ways the worst time to be an economic geologist student, in some ways the best way. It's the worst because so many universities are dropping their programs, but it's the best because when I was a young geologist, no one wanted to help me do anything. And I would say those of us in our mid-career are just absolutely desperate to help because we need help. And so we want to train you to be good, to please help us because we're drowning. So I think this is a really good time to reach out to people and make those practical networking connections.
Awesome. Well said. So with that, I'll kind of summarize our key takeaways for this session. Fundamental geology is key. If you don't know what that is, or you need a supplement from your program, or maybe you're in a geologic program that doesn't have economic geology, use SEG or the network there to supplement that, right? Fight for the time to obtain the deep knowledge, domain knowledge, whether you're a student, early career, or even a senior leader. Try to learn how to fight for that and work with your peers to understand how to empower each other. Critical thinking and reflection on your geology and ore body knowledge is so important. If you forget how to do that, just again, go back, work with your peers, work with your network to ask what everyone else is doing if you see someone who's doing it better. And empower yourself and the geologists around you to be geologists, as well as innovators and investors and inventors as well. So with that, we will kind of go into the wrap up of the session for today. And I want to highlight a few of the upcoming SEG events up here. We have the Metals, Sustainability and Society webinar on November 17th. We have a SEG Distinguished Traveling Lecturer on December 8th. And then we have a virtual short course on drilling, dealing, and dropping, and exploration and decision-making through the commodity and project cycles. As a reminder, SEG is excited to announce that they are hosting the 2023 annual conference in London, which will be August 26th through the 29th next year. And the topic is resourcing the green transition. And the conference will address the major challenges presented by the acceleration of the consumption of energy transition and other strategic metals. The context is going to be global, with a spotlight of the European dimension of the different domains, past and future exploration, and mining potential. Field trips and workshops are being worked on right now, so stay tuned and follow the website for the latest information. Now, to kind of wrap up, as I mentioned in the beginning part of the session, this is our last webinar of the 2022 series, and I do want to take a minute to thank all of the previous and current panelists for the season, as well as really to remind everyone that although we might be doing this live right now, you can view the archive recordings from previous exploration and technology webinars on the SEG website. And with that, I just want to thank everyone for joining and participating. Hopefully this session was meaningful, and we really appreciate your precipitation. And again, thank you so much for being a SEG member. And if you're not one and you are interested, feel free to reach out. And the last thing to just note, if you are able to take the 1-minute survey that allows us to make these sessions better and better each time. And thank you again for attending. Have a great rest of your week. Thank you.